Hi everyone, this is your math guru. In this video, I'm going to show you how to apply your trigonometric ratios and your Pythagoras theorem. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. The diagram shows a simple bridge which is supported by 4 steel cables. Find the angles at alpha and beta, and also B, find the length of each cable. Starting with the first part of the question, in order to find the angles at alpha and beta, I will start by highlighting the right angle triangle to use for each question. And if I draw a quick sketch, I have my rectangle as shown. I have my 90 degree. The height of the pole is 6 meters. The distance from the pole to the first cable, that's 4 meters, as shown in the diagram. And then I have my alpha. In order to determine the trig ratio to use, I will state the acronym, that's SOHCAHTOA. This just helps in remembering the ratio for each trig function. And in order to determine if I'm going to use my sine, my cosine, or my tangent, I'll start by labeling the sides of my triangle. The side facing the reference angle will be my opposite. Then I have the longest side, or the side facing the right angle, as shown, is my hypotenuse. The last side will be my adjacent. A triangle has 3 sides. So therefore, if you look at the diagram, in order to determine the alpha, or the size of angle alpha, I have my adjacent and my opposite given. If I go to my acronym, the trig function that uses opposite and adjacent is my tangent. So therefore, I have my tan of the reference angle, which is alpha, equals opposite, that's O over A, over my adjacent. I have my tan alpha equals opposite is 4 meters, and my adjacent is 6 meters. To find my alpha, I'm going to move my tangent to the right hand side, and once you cross the equal sign, it becomes the arctan of, let me put that in a bracket, 4 over 6. To find the arctan on your calculator is the second function of your tan button. So therefore, alpha equals 33.69 degrees to do 2 decimal places. In order to find the angle beta, note that the angle beta doesn't start from the pole. It's the small part as shown. So the first step is to find the whole of this angle as shown using the bigger right angle triangle. I'm going to draw out a rough sketch. I'll call that angle theta. So if I have theta here, I still have the height of the pole, 6 meters. Now note that for the adjacent, or for the base of the triangle, it's going to be the total distance from the pole, which is 4 plus 4, that's 8 meters. So like I did earlier, I'll start by labeling all the sides of my right angle triangle. The side facing my reference angle will be my opposite. Then I have the side facing my right angle, that's my hypotenuse, and the last side will be my adjacent. So in order to determine the trig ratio to use, because I have my adjacent and my opposite, if I go back to my acronym, the trig function that uses adjacent and opposite is my tan. So therefore, I have the tan of the reference angle, which is theta, equals opposite over the adjacent. Tan theta equals opposite, which is 8, over adjacent, which is 6. So therefore, in order to find my theta, I'm going to move my tan to the right hand side. And once you move any trig function across the equal sign, it becomes the arc of that trig function. So in this case, I have the arctan of 8 over 6. To find the arctan is the second function of the tan button on your calculator. So therefore, the value of theta equals 53 0.13 degrees. But we're not done, because the question says find the angles at B, which is a beta. So therefore, beta plus alpha will give me my theta. That's the total angle. So therefore, beta will be my theta minus my alpha. From the first part of the question, I calculated theta alpha. My theta is 53.13 degrees minus the value of alpha, 33.69 degrees. So therefore, my beta equals 19.44 degrees to 2 decimal places. For the last part of the question that says find the length of each cable, I'm going to tag my cable A, B, C, and D. Note that cable A is the mirror image of cable D, and cable B is the mirror image of cable C, so they have the same length. So I just need to find the length of cable A and B. I'll be able to find the length of cable C and D. So starting with the first one, I will be using my Pythagoras Theorem. So I will use the bigger triangle as shown, and then drawing out a rough sketch. I have my 90 degrees, I have my A, I have the height of the pole, which is 6 meters, and the total distance for my base, that's 8 meters. So using my Pythagoras theorem that states that the hypotenuse squared equals the sum of the square of the other two sides. The hypotenuse in this case is my A, so I have A squared equals x squared, that's the base, so that's 8 squared, plus y squared, that's 6 squared, A squared, that's equal to 64 plus 36. A squared equals 64 plus 36, that's 100. And to find the value of A, I'll find the square root of both sides in order to cancel the root sign or the square. I have the value of A equals root of 100, which is 10. And don't forget to put your unit, that's in meters. So therefore, if the length of the cable A is 10 meters, what it means is the length of cable D will also be 10 meters. Then to find the length of cable B, which is also equal to C, I'm going to start by showing you the triangle to use. That will be the smaller one. And if I draw out the rough sketch, I have my 90 degrees, I have the height of the pole, that's 6 meters. Then the base this time around will be 4 meters, and the length of cable B. Starting with the formula, r squared, that's the longest side, equals the sum of the square of the other two sides. The length of the cable B is my r, so that's b squared, equals 4 squared plus 6 squared, which is 16 plus 36. Then I have b squared equals 16 plus 36, that's 52. And to find b, I'll find the square root of both sides. So therefore, the length of cable B will be square root of 52 to 2 decimal places. That will be 7.21 meters. So note that cable A is equal to 10 meters, which is also equal to cable D, and cable B equals to 7.21 meters, which is also equal to cable C. Thanks for watching. Bye.